All right, welcome to the Hyperloop SolidWorks CAD workshop part 1. So if you weren't aware, there's gonna be part 1 and part 2 of this workshop. So today we'll be focusing on part modeling. And then next week we're gonna do like assemblies and drawings, animations, and all that kind of stuff. That gives us more time to focus on both sections. But before we get to all that, we're gonna start with, the basics of what is CAD. And I'm going to figure out why it is not showing the whole screen. Come on. There we go. All right, so what is CAD? Start off with. So the CAD stands for computer aided design. And it's got, a couple different parts to it. So 3D modeling, that's kind of what we're doing today. That's Autodesk Inventor, Fusion 360, SolidWorks. There's PCB design, which we're going to teach later in the semester. So that's CAD specifically for designing PCBs that you connect circuits to. There's CAD for architectures. That's, Revit, Civil. If you're an architecture major, you're going to be doing like Rhino or SketchUp. Maybe for landscape, you're going to do that too. And then you could also be using stuff like AutoCAD for 2D drawing or planning. And there's, of course, a lot more softwares. This is just like a very small subset. But the gist of it is that, whatever it is that you need to design, you can do so on the computer. Why do we CAD? Obviously, computers can do things much more precisely, so it's great. It's a lot easier to see the dimensions here. It's also great for manufacturing. So again, if you're doing like 3D printing or laser cutting, CNCing, you can translate your CAD models into what's called G-code. And I can talk a little bit more about that later if you're not familiar with what that is. But the gist of it is that you can give directions to a CNC manufacturing machine that will allow it to create what you modeled. CAD is also great for like dimensions and all kinds of stuff that we can't really do by hand, especially for making 3D models, like trying to make little sculpture models, not super helpful. So this is just a good way to do that. What are we doing today? We are going to do 3D modeling. We are not going to do Fusion, that was the plan, but we're only Fusion SolidWorks. But if you have if you ever want to use a different program, Fusion is it's a much more probably user-friendly one, and it's available for all students if you have a student email. So even if you're not a college student, you can get that one. SolidWorks, that's what we're doing today. That's kind of like it's what we mechanical engineers learn. That's like what they teach us here. It's one of the more probably standard softwares. On-chip and Tinkercad, those are like some more, not quite a professional, but they're free and they're online. So you can also use those if you're looking for something, free. And then Blender, which I'm not as familiar with, but I think maybe that one's more for graphic design. So important topics. Oops. My back button's broken, so we're going to pretend oh, here we go. Sure. Are you guys okay with that? Turning off the lights? Yeah? Right. So something we're going to talk about today is, 3D modeling with manufacturing constraints in mind. How to, show what your model looks like. And we're not going to drawing today. We'll do that next week. But I do have a sample drawing here of the part if any of you need to see it. And so we'll talk about how to do this next week. Examples. So this is, as was asked, this is what we're doing today. We're not going to do the whole thing. We're just going to do the case. So this one right here. Next week, I'll provide you with the rest of the parts, and I'll show you how to assemble all of it. So yeah, hopefully you enjoy the modeling. I had this idea to do like a planetary gearbox, emphasis on the planets. And I made some different color planets. So you can all play around with this next week and, choose whichever colors you want. Their examples, this was the Hyperloop Mini from a couple years ago. These are actually designs from our former president. I did not do these. So with this one, this is LiPo RC car. And battery vending machine, this is for Banshee. These are all done in Fusion. And then if you came to our workshop on what was it? Circuit construction, you got one of these. This was the case for the little battery pack. All right, so we've gone through that part. Let's talk about measurements and tolerances, right? So first of all, does anyone know what tolerances are?
Acceptable range of limit for measurements.
Perfect, yeah. So tolerances are like, you know, like kind of exactly what you said, like what is acceptable. Kind of an acceptable margin of error is probably a good way to think of it. You know, how off can this part be from the exact dimension we planned? So that's important for manufacturing because as we know, manufacturing is not precise. There's always going to be some error involved. And especially with stuff like 3D printing, all materials, if you don't know, they have a coefficient of thermal expansion. And so if you're making a cast part or a 3D printed part, the part that comes out is going to be a little bit smaller than the dimensions you planned for if you have not accounted for that in your planning. So that's why you do these things like test prints or test fit strips, so that you can see right here when you 3D print. So before you manufacture something big and important, you waste a lot of time on, you make one of these little test strips to make sure that your tolerances fit, so you can fine tune your dimensions. Any questions on that? By the way, if I didn't say this, feel free to interrupt me at any time. And yeah, so know how materials interact with each other. The MPLA, both materials will shrink because of that coefficient of thermal expansion. I'm sorry, I can't talk. Metal actually does shrink. But the point here is that if you have like a screw or something, that's not going to shrink because it's already cast. So if you have an existing metal part, the PLA is going to be the one that you have to adjust. Continuing on with tolerances, this of it is just account for this during a 3D modeling. And it's fine if you get it right the first time. That's what these test strips are for. That's that you don't screw up a big, important, time-consuming piece over something as simple as tolerances. So again, there are going to be these issues with manufacturing that's going to cause some error. So with the 3D printing, nozzle error or material shrinkage with the PLA. Laser cutting, that can be material dissipation from the heat of laser. And then PCB design, the traces all have, there can be some, how do I put this? There's always a little bit of error with how they make the PCBs. So you have to have minimum distances between the traces to make sure that there's never any overlap, because that'll cause a short. So if you ever, we'll talk about this more during PCB design, but if you ever make your own PCB, you have to check your manufacturer's website, because they'll give you the specifications of what kind of tolerances they can accommodate. So have any of you ever used a caliper before? Yes. Okay. So all of you know what calipers are. Yes. Okay. I don't think I really need to go over it, but again, just precise measuring devices. You've got right here, right? This is for measuring the outsides of parts, insides of parts. This is for holes, and then depth is right here at the. So you can use these to make sure that your parts, just make sure that you're going to accommodate. If you're doing let's say you need to house a battery, right? You need to measure the battery first to make sure that your PCB, to make sure that your case can accommodate that battery. But again, PLA shrinks from printing. So if you print a design with specific dimensions, be aware you might have to adjust it a little bit. And you can actually do that in, hi Maria. You don't necessarily need to do that in your modeling. You can model with the exact dimensions. And then you can take your slicing software, which is where you it's where your design in CAD becomes your G code that you tell the machine, and you can scale your model up or down on that software. So that's something that you can do instead of modifying the dimensions in your program like SolidWorks. How's your status on SolidWorks download? 8%? Ooh. Okay. If nothing else, we'll have you sign into virtual lab. Because you can do that as a university student. And how's your virtual lab coming? It's working? Okay. Yeah, so more on calipers. I don't know that we really need to go over this as much. I think we kind of went over it already. Inches and millimeters. All right, so this is what I really want to talk about, is design for manufacturing and assembly. Who knows what these are? Oh, not the picture, just designing for manufacturing. Yes. Kind of. So the schematics or blueprints are how you tell your manufacturer what you want the design to look like. But the idea behind design for manufacturing is that you're basically going to design it with the idea of how it's going to be manufactured. So you're going to accommodate the equipment used to make it. So for one thing, don't have unnecessarily tight tolerances. If you have like super tight tolerances of like, maybe, I don't know, 0.01 inches or something, and it doesn't need to be 0.01 inches, that just adds additional cost and time and manufacturing constraints that you don't need. So make sure that your tolerances are not unnecessarily constrictive. Constraining. I don't know what word I was going for here. But you all get what I mean, right? Okay. Understand what material you're working with and choose an appropriate manufacturing process. So I think in most cases, a lot of us are using like PLA for 3D printing because it's cheap and easy to work with, and 3D printing is good for, rapid prototyping. But that being said, if you've got like, a metal or something, right? If you're working with steel or aluminum, you're going to have to choose your tooling appropriately. So the stuff that works on aluminum isn't necessarily going to work on steel because steel is a lot harder. If you're working on steel, you're probably going to need like lubrication fluid, and so the machine has to be able to accommodate that. Stuff like that. Just keep this stuff in mind when you're designing. Consider quantity as well. If you're going to do, who knows what plastic injection molding is? You all know, familiar with the concepts? Yeah, so plastic goes into molds, right? And then it hardens and comes out of the molds. But those molds are really expensive. So if you're making a really small quantity, there is no reason to make it plastic injection molded because you're spending additional cost on, this equipment that you're only going to use a few times. So again, just in your quantity. Don't make geometries that can't be manufactured. So that's where the snail comes in. I don't know if you've seen these. There are snails, they print stuff like this at the Maker Studio. And these snails are special because they can only be manufactured by a 3D printer because of the internal linkages. That kind of, I wish I had a picture of the way that they worked. But basically they're printed in place by the machine. So they're printed together. And they can only be manufactured by a 3D printer. There is no other machine that can do them. So keep in mind, if you're making parts like that, just make sure that you know what machine you're working with, because if you create something that cannot be manufactured by the machine, you're in trouble. And then the rule of 10, which means that this is kind of a ballpark, but it's something that's discussed in industry, is like at each new phase of product development, the cost to make a change is about 10 times more than the previous phase. So if you're in like the testing phase and you realize something's wrong, it's going to be 10 times more costly than in the design phase. In the production phase, it's going to be 100 times more costly than the design phase. So you want to make sure you get it right in the design phase. Does that make sense? Okay. Designing for 3D printing specifically, try to minimize print supports. You can see this, the glasses right here. Do you think there's another way that could have been printed to avoid all these extra supports? Yeah, so this is just like an inefficient way of manufacturing. You're wasting material, you're wasting time. It's gonna be a lot more labor intensive for you when it's done to like get those supports off. So keep in mind when and we'll go over this during 3D printing, but if you're making something like this, try and make sure that you're orienting it correctly so that you don't have to deal with all those, supports. Remember I'm sorry, I can't talk. Remember that is being manufactured from the bottom up, just keep that in mind. Or in SLA printing, I guess it would be the opposite, but just remember that's additive manufacturing, so you're gonna have to account for that. And you see like this right here, this is an infinite Z-axis printer, so it's a little bit different. This right here is an SLA, so it's kind of in reverse, it builds from the top down. And then this is just normal 3D printing. So all of these manufacturing processes are different, and they're all going to require you to kind of, you know, think accordingly and plan accordingly. Oh, and that's another SLA. Everyone familiar with SLA versus FCM? Okay, FCM stands for fusion deposition modeling. That's kind of your normal PLA 3D printer that you normally see. Right, melts the plastic, deposits it in layers. An SLA printer uses a photosensitive resin. And so what it does is it has, you can see right here, there's light. That's a UV light on the screen. And so it lights up with a cross-section of that, lights up with a photo of that cross-section and makes the resin harden because it's photoresin. So it hardens when exposed to UV light. So it hardens on the cross-section and kind of builds the model that way. Make sense? So designing for assembly. This is something I also want to talk about. Use as few parts as possible. So you see this right here? This is one of the big upsides of electric vehicles is, you know, your normal, like, you know, just electric motor, and then your internal combustion engine. One moving part, I don't even know how many moving parts. One, less time to assembly, and two, there's just less things that can break, less things that can go wrong. So it's a much more reliable design. Yeah, easier to assemble and less parts that can break. Use common or existing parts where possible, and make parts that can be quickly assembled by common tools. You see those screwdrivers right there? This list of screwdriver? Yeah, okay. So I don't know who on earth uses these ones at the bottom. I've heard that some people do it as like a security thing. Like if you're a special company and you don't go messing with your stuff, you make like very, very specialized screws that no one else has the tools to deal with. But if you're designing something like at home, don't make your own screws. Just buy the screws that exist. If you're, if you're making like a consumer product, use the screws that everyone has the tools to disassemble and assemble. And this is probably common sense, but I feel the need to reiterate this. Is like, just use common screws and tools and all that kind of stuff. Don't make parts that all look the same, but are used for different purposes. So if there's different parts for different things, make it very obvious. Otherwise it's easy to confuse parts and things can go wrong. Have you all had that experience where you're all trying to like assemble something from, the store, right? And you're like, oh my gosh, these parts all look the same, but they're slightly different and you can't really tell? You all have that experience? No? Okay, I've had that experience assembling furniture. It's really annoying. Things can go wrong easily. So, it's easy to just like put like an embossed letter or something on a part, just make it obvious what's what. Make parts symmetrical when possible, because otherwise they can be oriented wrong by the assembler. That's important. And I think, you can go more into depth on this. This is just kind of a basic primer on like, simple things you can do to make it easier for yourself and for other people if they're assembling your designs. Everyone good? Okay. And then circular design. So this isn't something that gets touched on a lot in engineering, but it's something that I want to cover. Does anyone know what this is? Any guesses? You were here last time I presented it, Chantal. I did talk about this. Okay. I'll give you the the explanation. So circular design means that, we have a finite amount of resources here on Earth. So we're trying to design parts that you know, can be reused again, or can be, you know, we're caring about what happens to them after they're done, after we've used them, and, you know, do they go to a landfill? Do they go to a compost pile? Can they be recycled? Stuff like that. Can they be reused? How can we easily can it be disassembled? Yes.
Is this like lean manufacturing?
Is it what?
Is it like lean?
What manufacturing?
Uh,
What? I'm not familiar with that term. What is it?
This one, you look at the device and you try to, make sure that it's in line, it's able to be reviewed.
Oh, cool. Yeah, it's basically the same thing. I had heard that term before, which is cool. Yeah. So, and again, most of these things are just like good design principles too. So tips number 1, again, designing products to be serviceable, easily fixed, and easily disassembled, so they can be reused or recycled. You know, minimize the number of components, minimize the number of joints and connectors. If you've got a lot of screws, it's hard to disassemble. Anything like, if you see right here, these are like snaps, which are much easier to assemble and disassemble. Also, just make sure, like, easier as someone who has to assemble stuff. If you remember all those, if you didn't even get the voltage regulator boxes with battery, for those of you who don't know what I'm talking about, hang on. It is this thing right here. And you can see it's connected right here with 4 screws. I remember all of you bored last year sitting there with screws for hours assembling these things. It would be much easier if we had something that snapped in. So again, if you're making stuff like this, it will make your life so much easier if you use snap fits. I can't emphasize this enough. Oh, nope, I'm not sharing. Nope. Sorry. Okay. So again, consider your joints, connectors, fasteners. It just went through this, but you know, you've got latches, snap fits, clips, and even bolts and screws. Those are better than fixed connections like welding or rivets or glues, because those are a lot harder to disconnect. Try to avoid irremovable coatings because it makes recycling really hard. Make sure that you can design it for damage-free assemblies, that parts can be reused. It's not going to be something where once you assemble it, it can't be disassembled without damaging it. Also means good labeling and documentation. Like, make sure that your instructions for part design, or not for part design, excuse me, for part assembly, if you've got good assembly instructions and disassembly instructions, just again makes it so much easier. Everyone, does that make sense? Let me give an example, actually, this third one, irremovable coatings. Does everyone, just curious, raise of hands, who thinks that like paper drink cups are recyclable? Okay, now we know it's not. But they look recyclable, right? Because they're paper, but they actually have like a plastic liner on the inside to keep the drink from filling out, but that makes them not recyclable. Some of them, yeah, a lot of them do. So again, like, most of the time you can't tell. And sometimes they're there for a reason, obviously. But if you can avoid them, you should avoid them, just for the sake of being able to reuse parts and recycle parts. And then design tip number 2, use as little material as possible. So if you can increase your strength by using geometry instead of mass, that's always, you know, ideal. Avoid unnecessary components. And again, if you're avoiding like extra mass, that's less material, so you have to pay for less as a manufacturer or designer. So again, this is just like, these are just like good design principles. It's not just about circular design. Like, this is just good engineering. So you can see right here, right, the truss structure, that's this principle of, you know, geometry instead of mass. Same thing with these ribs right here, right? So instead of having all this extra material, you're just using a little bit for strength. Make sense? Okay. We'll get to the CAD modeling in a bit, I promise. And also, part design, I want to go a little bit over like stresses, because I don't think we've ever covered this before in a CAD workshop. but stress concentrations are really important. And I think most majors don't get to do this. I think it's only us mechanical engineers. So stress concentrations, these occur because of abrupt changes in geometry, like really sharp radii, or sharp edges or small radii. So if you can increase the radius of curvature, that reduces the stress concentration factor, right? So if you've got like a sharp corner, if you curve it, that helps a lot. Also, if you've got these like the shaft stress concentration right here, if you go directly from like a really big radius to a really small one, that's going to cause much more stress here than if you've got like a bigger one going to a medium one. If you've got, I'll explain fillets and chamfers in a bit, but if you've got a fillet, that's going to provide a lower stress concentration than a chamfer because a chamfer has more edges, and I'll show you the difference, I promise. And then any holes, notches, or cracks are going to be stress raisers. Like those are going to be areas of concentrated stress. Everyone knows what stress is, right? Okay, and why we want to avoid it in part design? Someone raise their hand? No? Okay. So to continue, right? Don't use like sharp corners along the load path. Oh, so right here, you can see that's a chamfer. A fillet would be if it was just like a smooth curve. But you can see, right, a sharp corner versus a chamfer, this is the better design. I think I went over this. Don't make large size transitions between loaded features. It just means if features are under stress, don't, go from a really big one to a really small one. Try and make it more gradual. Use uniform materials when possible because variations in material properties that can cause stress concentrations. And you can also add, this is a little counterintuitive, but you can add extra holes or notches in strategic locations to kind of dissipate some of the stress and help to redistribute it so that you can prevent it from concentrating at certain points. Also, if you're going to do that, try and use a couple of smaller holes instead of a really big one because it facilitates smoother flow of stress. Also, you can see right here, there's examples of ribs and gussets. You can use these to kind of redistribute stress away from concentration points again and to strengthen critical areas. So, yeah, I know we didn't really get to do a whole lot of it, but just something I wanted to show really briefly because, again, I don't think we've ever covered this and it's important. Any questions? Am I talking too fast? Okay, I get that a lot, so if I am, let me know. How's upload or download looking? Okay. Start logging into the virtual lab. Or search CPP virtual lab and you should be able to log in with your credentials. All right, modeling tips. So additive and subtractive manufacturing, again, we touched on this briefly, I think, before. You can see right here if you've got an original model, right? Additive manufacturing means you're adding parts onto it. So that's 3D printing, and that's kind of well, actually, we can do both. In CAD modeling, you can do both of these things. Excuse me, sorry. But manufacturing is to be one or the other. So if you've got additive manufacturing, that's going to be like your 3D printing. Subtractive manufacturing, that's going to be like, routing or milling. That's when you're moving material instead of adding it. Make sense? File types. So I think there's a different way to do this in Fusion. In SolidWorks, you just save it as one of these files. So there's like a drop-down menu and you can pick a file to save it as. Step file, that's for kind of if you're importing a CAD model to different software. Like I was going to make something in SolidWorks and send it to another person who needs to open it in Fusion. I'd use a step file. An STL model, that's what you'd use for slicers if you're doing a 3D printer. So you'd save it as a STL and then upload it to your slicer as an STL file. Object is kind of what you save it as like in your own program. And then G-code, these are the instructions sent to a machine to create a model. So again, if you're doing 3D printing, you upload it as an STL and then you slice it and that converts the STL model to G-code. Modeling basics. So it's not super crucial, just the way that you see like objects, different points. If you've got like, so you can see right, this model, this is the isometric view. This is where you're seeing the whole thing. And you got the front, right? You're seeing it from this perspective. So you got, top piece, bottom piece, and side. You can't really see depth. The top, you're gonna see, again, these three pieces and that triangle piece. Right, and then the side is, same thing. You've got, just those two main pieces. So you'll see it in SolidWorks when you get into it. There are all these different views that you can use. So you can click on, top view, front view, side view, bottom view, etc. Or you can just kind of play around with it in 3D. By the way, did everyone bring a mouse? Yes, okay. If you didn't bring a mouse, it's gonna get a lot harder to model. All right. Sketches, you'll see this again when we get into it. But this is kind of where you start. So a lot of times you'll create a sketch. And then that sketch will be, revolved or extruded or cut, whatever. But you always start with a sketch and then you create 3D models based off of that sketch. Constrained versus unconstrained geometry. We'll talk about this again when we get to the modeling. But a constrained geometry is always going to appear as like a solid black line. That appears when you have specified the exact position and exact dimensions. So it has to be constrained or dimensioned in relationship to the origin point, which I'll show you. And you have to have dimensioned it exactly. And that's usually the best type. Yeah? Raising your hands? Oh. It has to be, constrained is usually considered the better type of sketch. But it can also be unconstrained. Sometimes it's more important, sometimes it's less important. Especially when you're starting out, constrained geometry is probably better, but I'm not. If some people are super picky about it, I'm not. You'll also be able to make sketches on the faces of objects and be able to build pieces out like that, which you'll see we'll do later. And constrained is black, unconstrained will be blue, and constrained is kind of locked in place. Unconstrained is not, it can move about. So examples, right? Unconstrained, right? Blue, constrained, black. You'll see this when we get into SolidWorks. And then basic functions, extrude, cut, loft, sweep, revolve, hole, fillet, chamfer, shell. And we'll see most of these today. So these are kind of like your basic tools. And, we're doing SolidWorks today, but these features exist in like every single 3D modeling software there is. So once you understand them in one software, you can apply them to any other software you want. But again, these are basic building blocks. And here we are. I think we're ready to do modeling. So, yeah, let's get rid of this. Open up SolidWorks. Can they see me in SolidWorks? Share. All right. Hope everyone on Zoom can see my SolidWorks. Are you in virtual lab yet? You're in? You got SolidWorks running? Voting? Okay. And everyone else is good? All right. So, Maria, do you need time to get your computer out?
So I can get that in virtual lab.
In virtual lab, yeah. Okay. So you don't have SolidWorks downloaded yet? You don't have SolidWorks downloaded yet?
No.
Okay. We are a little early, so we plan to have like 2 hours to do the modeling. So we can wait for everyone to get it up and running. So if you guys want to just like chill for the next 5 or so minutes and then we'll get started. All right, and let me know when you're ready. Just curious, who here has never used SolidWorks before? Never used SolidWorks? All right. Interesting. Cool. And the rest of you, how much practice do you have? Like, huh? 2 years SolidWorks experience? Nice. Okay, cool. Do you want me to turn the lights on or are you good in the dark?
It's going to because, maybe it's send the signal.
Okay. Thermostat should be regulated by temperature sensors and not light sensors, but I can keep the time too because it's late. Do you want the lights on? Yeah. Okay. You can also send screen, right? It's downloading?
No, but chart, loading.
Okay, let me see. All right, cool. Let me know when it gets to 100. Are you good? Great, thanks. You're good? Perfect. All right, so we'll wait till like 4 minutes. Maria, just let me know when yours is ready. How many of you have not been to a Hyperloop workshop before? Have not been to a Hyperloop workshop before? Like this is your first time ever coming? Cool, okay. How'd you hear about us? Like flyers or Discord? Flyers? Okay, cool. Nice. Let's go. Yeah, can try again. Sure. Yes. Oh, yeah. 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 I don't think we have to do the 5 buttons.
No. It's up percentage.
Yeah.
Huh?
So we actually supposed to be here today teaching religion.
Oh, these actually.
Yeah, it's the same concept, it's just the program.
Oh.
So both will do the exact same thing. One is just, yeah, it's like Python versus like Java, right? You do the same stuff in both programs, it's just. No, CAD is computer aided design. Oh, that's like, it's a, well, it's computer aided design, so there's like you can do, like engineering CAD, you can do design in CAD, you can do like Revit or Rhino for architecture, dash CAD. So it's all under that umbrella. No.
Just introducing sort of very.
A little bit, yeah. Oh, there we go. Okay. And if you saw CAM, CAD stands for computer aided design, CAM stands for computer aided manufacturing.
Oh.
So these are all CAD CAM software.
So is that log in?
Log in. No, just part. Yeah. No, this is what yours is. You can just do this, just like the whole thing. Like on the edge. Yeah, it's easy. Yeah. All right, so we're already in the. All right, is everyone where I am? Yes. No. All right, yeah, all right. So what you're all gonna do is, if you don't already see the screen, go up to new, and you should see this. Does everyone see this? Does anyone not see this? Huh? Yeah. I mean, like, does everyone not see this on their computers? Okay. Part. Click OK. Wait for it to load. And then you should get this screen. Does everyone see this on the computers? Yes? All right. So a couple of things about SolidWorks first, addressing some of the big kind of very common mistakes that I see, or especially in like last semester when I was helping out with this. In SolidWorks, a lot of people have this tendency to like try and click and drag, and that's not going to work. You need to click and release, then drag, and then click again to anchor. Everyone got it? So click, release, drag, click again. Otherwise, it will not work, and you'll be sitting there trying to figure it out, and it will not work. Other thing, if you're like need to get out of command, like let's say you hit like the line tool, right? And you just keep making lines, hit escape. A lot of people do that as well. Where like they're like, I keep making lines, I can't get out of it. Hit escape, you're good. If you made an extra line by mistake, click on that line and then hit your delete button. You can also, well, I'd have to do it first, but if you right click on that line and then pull up menu like this, there will be a button that says delete and it'll be a little red X on it. I'll show you that later. If you would like to, so once you do a command, right, if you make a line, a shape, do a feature, right, usually in this panel here, you will see like options, and once you're finished with those options and you want to confirm it, you hit the green check mark. So there'll be a green check mark here and a red X, and there will also be a green check mark here and a red X. The green check mark is to confirm and finish the action. The red X is to cancel. Again, one of the really big mistakes I see is like people are like, oh, what do I do now? I thought I finished it. Hit the green X, hit the green check mark. If you made a mistake, hit the red X. If you need to, so does everyone have their mouse? If you want to kind of rotate, you hit the roller. What is this called? Hit the roller, and then hold and drag, and that kind of you'll see it when you do it. That's how you kind of like rotate your model. You can also come up here. This is, front view is right there, top view, bottom, left, right, and back. So if you need to go to any of those views, which I think we talked about a little bit in the presentation, that's how you do it. All right, so everyone feels like they're ready to get into it. Okay, so these are kind of your sketch planes that you start off with, front, top, and right. So what you're gonna do, you're gonna hit the front plane. And then why do I have no, what happened? Give me 1 sec here, my program's acting up actually. All of my tools up here got moved. Hang on. No, those are extra tools that I added. Looking for toolboxes. No. Here we go.
I just had to when I was looking at that. I like you that was really far. Really long.
This was working earlier today, I promise you guys. You know what? All right, I'm just gonna do this and try again. Huh? Oh, no, you don't need to do what I do. No, do not follow what I did. I was just trying to fix mine. I promise all of you, I went through this process earlier and this was not happening. Are you kidding me? Okay. On Earth. It's really annoying. Do you know how? Yeah. Thank you. You're amazing. All right. Okay, thank you so much for your help. Okay, now we're ready to start. Is everyone here? Yeah? Okay. I don't know what happened between like a couple hours ago and now, but thank you for your help. All right, as I was saying, to your front plane, go to this, you see the sketch tab right here? Go to that and then hit this button sketch. You see that sketch tab right there? Turn features, go to sketch, and then hit the sketch button. Do you see the sketch button? Yeah, okay, hit sketch. Everyone good? Okay, you see this circle button right there? Hit circle. And then you're gonna hit this right here. You see the two red lines are? That's the origin. So hit the origin and draw your circle. I'll tell you that later. Just draw a circle. We'll mention it in a sec. Everyone good? Anyone not have a circle? All right. See this tool right here called Smart Dimension? Everyone click on that. Smart Dimension.
Should be right next to the exit sketch, right? On the top.
Oh,
Yeah, you see it? Okay, click on that. And then you're gonna click right here on the outside of your circle. Oops, nope, not that. Okay. Everyone see this on the computers? All right, once you got that, click. And you should have a dialog box pop up. Everyone see it? Got it, Maria? Okay. You're gonna type in 6 for 6 inches. Is everyone's display in inches? Yeah, you can. But is everyone defaulting to inches?
Yeah.
Okay. So type in 6. You can also put in 6 inches, like she said, which I can show you right here. And then either hit the green check mark or hit enter. And now you have a 6-inch circle. And now you can see we've got right here, this is a black line because we just dimensioned it and because it was constrained to the origin. That's where we started it. You will also see that this is a shaded circle. That's because it is a closed shape. If you have an open shape, it will not shade. And so that's actually a good indication if there's any problems with your sketch is that it will not be shaded. And you can actually fix that very easily by coming up here and seeing repair a sketch. Where's that tool? So we can do that right now, but if you click on it, it'll say show gap smaller than, you know, whatever. And see that no problems found right now because I don't have any. But if there's gaps, it'll identify where the gaps are for you. So you can see where the problems are. And that happens sometimes. It's just like a consequence of sketching is sometimes there's accidental teeny tiny gaps that you can't see. Yeah, so I think I explained all of that. Right, again, this is constrained. Now, what we're gonna do is we're gonna click this button called offset entity. Everyone see it? Yeah? Click that button. Offset entities, right here. Click that button, and then click on the outside of your circle. And you should see a yellow line pop up. Everyone see it? All right. So you see, this is where I told you all your parameters will be like going to appear on this window, whatever you want to call it, right? This is where all your options will be for whatever you're making. So you're going to see whatever's in there, and you're going to type in 0.25 inches. And then you're gonna hit this, you see this option right here that says reverse. You're gonna, excuse me, can't talk. You're gonna click that button. What it does is offset entities means that basically you're taking this, you know, whatever shape you've clicked, and you're offsetting it by a certain amount, which is what you just typed into the parameters box. And then this reverse button, that's, you know, the default here is for it to offset outside. So they're reversing it so it's offsetting inside. Does that make sense? All right. And once you're done, again, click the green check mark. This is what I was telling you about. We can also click it right here. Either of these will work. I'm gonna click here. And here's my shape. Everyone at the screen. 0.25, yes. And then you're gonna do the same thing again. So offset entities, pick that exterior circle, reverse, but this time you're going to offset it by 0.125. Yes. Click the outside of the circle, the biggest one. 0.125. Yes. So you want 2 interior lines. And click the check mark. Okay. Is everyone able to see what my screen shows on their screens? Yeah, okay. Yeah, you want everything, the 6 inches should be the biggest circle. All right, everyone good? Ready to move on? All right. So now what you're gonna do is you're going to create a vertical center line. So you see this line button right there? It's your line tool. Click the bottom, you click the down arrow. Hang on. There we go. All right. You ever see center line? All right, click center line. Good, Maria? What? What happens? Oh. Yeah.
Like, let's say I want to zoom out where you missed one of It's really good. Notice like,
Yeah, I see. Oh, yeah.
I would love this would if there were to just block this.
You should be able to just like do this, yeah. But why is about do you want to do them? Do you want to do them?
Oh, yeah, but.
Oh, no. Cutting with that. Oh, there you go. Let me get this right. The gun properties. Bucket properties. And then. That one. Yeah. And then. Right. Okay. Yeah. Anyone else have problem writing in the meters? All right. Again, like, do not be afraid to ask.
All right, Maria, you good?
Yeah.
Okay. Okay. So again, click line tool and this down arrow and click center line. Everyone there? Center line, yeah. And what that does is center line is like a construction line, which I'll explain in a bit. So you're gonna click this origin, right? Which should come up as like orange. And then hang on. Again, yes, click, hang on. Center line, origin, and then drag upwards. And to the top of your 6-inch circle. And hit escape. And you see how this line is dotted? So this is a construction line. And what that means is it's basically a reference line, is it's not going to create actual like geometry. It will not create closed shapes, but it's there as like a guideline for you to use to make other things, if that makes sense. And generally, if you click on like any line, like let's say I want to do this one here, you click on that line and there'll be a little checkbox on this left side here that says for construction. So click that and it'll become a construction line. I can do that for these two actually, because these are construction lines. Make sense? All right, everyone got that down. All right, now what you're gonna do is you're going to go to center line again, and you're gonna make 2 more construction lines just to the right of these. So both of them are gonna go through the origin and then up the top of the circle. and then hit escape when you're done.
Specific angle view.
I'll tell you that in a sec. So everyone good with this? All right, and you see how these are now blue instead of black because we haven't specified an angle? Because they don't have an exact position yet. You're gonna come over to Smart Dimension again. Smart Dimension is like our best friends in SolidWorks. And you're gonna click this vertical line. And then, oh, okay, cool point. You see this little thing that's popping up, the blue line that's popping up right to the right of my cursor? The really tiny one? So these are called sketch constraints. So because this line is perfectly vertical in relation to the origin, it's showing a vertical constraint. And it'll show horizontal constraints too, and I'll show you a little bit more about that later, but this is handy. So again, if you're gonna do, you're gonna create the angles, Smart Dimension, click the vertical line, and then click this outside line right here. And you'll see an angle. Everyone have that?
That's Smart Dimension and click both lines.
Click the vertical line and one of the other lines, yes. Got it? Okay, get the angle and you're gonna type in 4.5 degrees. .5 degrees.
Is there, that's a little line. Oh, I know what happens. So hit with those lines, just double click. Any of them. Just like double click really fast. There you go. Yeah, if it ever like grays out your screen, it just means you need to pick up the sketch again and go back to the sketch to edit it.
All right. And then once you have done that, you're gonna do it again. So Smart Dimension, click vertical line, and then whichever line you haven't dimensioned yet, whichever one is still blue. And you're going to dimension this to be 2.25 degrees, so half of what it was. I'll move that over so you can see it. Let me know when you're where I am. Good? No?
Yes. Okay. We'll start with the lines first. Two center lines. Yeah. There. To get both of those extra lines, you zoom up those to the right. So do those stretch lines just from the origin to the end. Yeah. You might need to take first. And then just yeah, it's annoying because it'll start moving and then changing. So if you hit the center line again, it would have gone from there back. No, right side. Yeah. Let's do the angle and get Smart Dimension. Smart Dimension. Just choose match. You kind of notice by default. So hit that vertical line. And then hit one of those other ones. And then, yep, and then pull it out. You see that angle? So if you move over to the center. Yeah. And then that's your, that will be your 2.25. The other will be 4.5. Yeah. Then do the same thing the other one, but. Okay. Okay. Anyone else need help? Yes. So what happens here? You don't need the vertical.
Yeah.
Okay. So to that line, the horizontal line, click on it, horizontal. The line up. From that, then right click. Right from the link. Or just complete. Okay. So, so this other line here, this line, like the outside one, see how it is 6 inches? So, yeah, we're going to need to get rid of this and then do the other ones that's inside. Or you know what, actually, you can just mention this. But you should be able to, here. Here's the image. So you can do. So draw these, yeah, so the rest of it looks fine. Zoom into that part right there. It's not. You know? So, right. That's a good fact. But if you can move this one up to the top, and then make those 2 extra lines. So this one, this dimension. These two are the side. So we should do. What's up? I didn't see it. Girl goes around.
Three, yeah.
When you didn't observe the beam, and the other end, honestly, I know it's part of the universe. Just because yeah, so then when we made the line, we want to make it the wrong side. Oh, so then when we try to change the angle of it, we decide. Oh, that one, okay. That's why it wasn't doing like angles, it was the angle. Yeah, so then like this. Don't do that, that's the last one we did. Like, side. Go all the way around. 6 inches. And slightly different. See how I are?
Yeah.
It doesn't need to be exact, just anywhere on that side that you stretch.
just not the point line. And hit the line. This you can try again. This you can. Okay, nice.
And you see the two vertical, it means that it's 1% higher.
Oh,
So
okay.
for that,
Mhm.
even if it's a lot smaller.
Yeah.
That's the way I do this. Now it's black. So black line means they already knows where to use.
Oh,
So then if I did something like.
David?
okay.
Now, I will just mention. So, right? That means it doesn't show you where it's being. This one is, try typing 2.5.
Okay, there we go.
Then you want to try it again. Then 1.5. There we go.
Okay, so that's like the 4.5.
The one I was.
And now do the other one too.
Uh,
Are you able to do that?
Oh, I see.
No, it's just in between. Yeah, it's in between the two. Let me know if you have any problems. All right. Ryan has to go.
How much was the offset?
Offset?
Yeah. One was 0.125, another one was what?
0.25.
Oh. Please.
Perfect. Looks good. Thanks for helping out. All right, everyone else doing okay? Doing good work?
I'm good here right now.
All right. So what you're going to do now, is you're going to go to this arc tool right here. This is the 3-point arc. Everyone see it? All right, so go to the arc tool. And then we're going to do is you're going to click here at the top of this middle line. And then here at on this bottom line. And then you're going to move it towards that bottom corner. Everyone got it? Yeah. So it's gonna be the middle, it's gonna be the bottom left quadrant of this like 4 quadrant grid you've just created. You're gonna click here and here. So put it in this bottom left quadrant. That is the 3-point arc. That's all right there. 3-point arc. All right, you guys got it? No? Who needs help? Yes. Oh, no, you're in circle. Here, go to the arc. Hit down arrow. Center part arc, you want. Yes, so make sure, you can zoom in a little bit.
How do we do that?
Hit the zoom button. Here. So just roll. Let's just roll. So move your mouse over that area, then zoom in. Just roll it towards you.
And I want to do that.
How do we roll do it?
Just I put this down.
Oh, try clicking and moving down. Or you know, try clicking that center. Yeah. There we go. Sorry. Yes. Yes.
Right. This one should be covered next.
The just got it on. As long as it's with the line, yes. Make sure to turn on it, yeah. And then click again, right there. Yeah, perfect.
And then
Perfect. All right. How's everyone else doing? Everyone is where I am? No? Yeah. No, it's perfect. I'll just click exactly where you're right now. And then bend in towards that bottom corner. Yeah, exactly. And then jump like kind of in between. Right there. So yeah. Right, and the feet to make sure you don't get them. Yes. All right, everyone else good? Yes, okay. You're gonna do this mention again. All right, smart dimension. So you're gonna hit the vertical line, right? That one that we've been doing before. Right here. Hit there and then hit not this entire line, but you're gonna click on just the top corner. You see that dot right there that's highlighted in orange? Everyone got it? Hit that dot and the line. And it wasn't even smart dimension. Hit the line. Hit that top dot. And then that'll give you what on earth? Yeah. The number is going to be 0.05 inches. And then you're gonna do the exact same thing at the bottom, but that's gonna be 0.09. Okay. Let me know when you're ready to move on.
same line by the bottom.
Yes. So the top is 0.5 inches from the side, or from that vertical line. The bottom is gonna be 0.9 inches from the vertical line. All right, is anyone having issues with that? Okay, so what you're talking right now is the material. It's because we attached it right there to that with the line. So that's a coincidence. Sketch condition. So you're gonna have to the line. And then do it again. Yeah. Perfect. And then now you do that. Don't turn the corner, start it from right there at the top. Don't do the corner, do the corner. It's not gonna let you move it over the side. You just do it anywhere on this line. Yeah. Then again, the bottom, here on the line, yeah. And then hit the top. Towards the side. Now play just, yeah, like that. No, hit, so, because we want actually one, two, three, like, spin it. And then. Yes. You can't spin it, just turn off the back of it.
Until bottom,
0.05, 0.05.
but those two are measured to be in relation to
the vertical one, not this, because you see this is actually the mission line. You want it to be this.
This,
right here.
so this line, this,
No, so 0.5 inches, 0.05 inches from this line to there. Is that funny? Right, okay, 0.05. And then
this,
to the same, that's the front.
this one, this,
No, from the exact same one,
oh, this one.
from this line to this. Yeah. You're good? Awesome. Now, once you've got this line. Chantal, you got it? Okay. All right. So once you're here, what you're gonna do is you're gonna click this, everyone see this button that says mirror entities? Oh, none of it matters. So as long as you got those two dimensions, we're good.
Just like the RC and the secondary.
No. Because you've got those two dimensions, that's all that really matters right now. So does everyone see mirror entities? All right, click mirror entities. Entities to mirror. This is the line you just drew. So click on that line. That make sense? All right, entities to mirror, click on the line you just drew. Mirror about. That's going to be this central, not the vertical line, but the middle line, the middle construction line. Everyone got that? And your new line should appear in yellow. Does everyone see it? Yes? Okay.
What do you want to type in here for about?
Mirror about, it's that middle construction line. The one that's highlighted in blue on my screen. And then click the green check mark to finish. And now you see you've got these two blue lines that are identical, mirrored about the center line. All right. So these actually not need to be for construction. I apologize. Did anyone make these for construction? Okay, make them for construction. Does everyone have the two solid lines and all the solid circle lines? Yeah? Okay. 3 circles, all solid lines, yeah. And you guys are good on over there? No? Okay. Let me know, because then I don't need to see it. Yeah. Click on mirror about. And then click the center line. Yep. So something looks off about here. Yeah, just okay. No, don't escape. Finish. Do that again, but let me see. Yeah, that should be right. All right, just do it. And then check mark. All right. Everyone good? Everyone right? You guys over there good? Okay. So now we're gonna do, did everyone see this button that says trim entities? Yeah? All right. What you're gonna do is you're going to get rid of these 2 parts right there and the entire rest of the circle. And then these ones here as well on the bottom. Huh? Trim entities, yes. So you have to kind of like move your cursor over the lines. And just click. No, don't do that. Click outside down here. Click and then drag. No. Click right there. And then drag down. No. Okay. Okay, yeah. Control yours. So hit right there, then drag the cursor down.
Yeah.
Exactly. Exactly. So anything your cursor goes over is better.
Oh, okay, then thank you, I do this.
Yeah, so you're already in advance, you don't need to. Yep. Right,
So we did this.
Yeah.
Huh? No, you're fine. Yeah. And then hit this bottom line too.
This one,
Mhm. And those two lines.
this one.
Mhm. All right,
And state.
yes.
What are the person names?
We don't just calculations, just don't worry about it. They're not important.
Thank you.
Honestly, I can, but honestly, it's fine. But let's get the question for you anyways. What's the dimension? I think the dimension I have on here is 0.24. So these should be 0.24 inch, radius of 0.24. Yeah. All right, everyone got that? I should have told you that earlier, sorry.
So, online, I have these green squares everywhere. How can I mean, green squares everywhere? How can I?
Just ignore them. They're just calculations. They don't mean anything. I mean, they do. They're there for a reason, but they're just information. They're not going to hurt your sketch.
Is there any, like, those?
That's probably some of the settings, but I don't really know which ones to press. I'm sorry. They'll go away eventually. I promise. All right. Yes.
I'm 3.5.
If it's blue, you probably just have the radius. The radius? Radius is 0.24. Sorry, I should have told you that earlier. Yeah. Just click on the arc itself and it should, that's one click should get you the radius. Everyone good on that? All right. I'm going too fast. Okay. This part is important. Pay attention. What? Radius line? Okay, just click on your arc and then that should, with the sketch, with the smart dimension tool. Then click on your arc and do 0.24. All right. Are you ready to move on? Okay. This is important. So you see this part right here, which says linear sketch pattern? So hit the down arrow and click circular sketch pattern. Linear is important. It allows you to do like grid patterns. Circular is what we're going to use right now. So, and click the what box that says entities pattern.
Yes.
Yeah. Everyone see the box that says entities pattern? All right. Click all these lines that you just have, that you made, the 5 here. What on earth? Hang on. Yes, I trimmed all the circles. I don't know why that's happening, but ignore them. Ignore the extra lines. The highlighted ones are all that matters. Has everyone clicked their lines? Did the lines look like light blue? Yeah? All right, almost there, Chantel. Everyone else is good? Again, if the answer is no, let me know. All right, for those of you who are ready, what you're gonna do is you're gonna change, this is the instance count. This is how many times you're gonna pattern it. You're gonna delete the 4 and say 80.
Oh,
And then click outside somewhere. And you should see them all pop up in this yellow border.
What else is, so 8 and then,
Let me see what your screen says. So those and that, okay, that's all right. Everyone seeing what I see on my screen? All good? Hey guys, you're gonna be super behind your own project, right? So. Okay, so go to the instance count right there. So it was 4. So there's, all right, yeah. Everyone got that?
Oh,
So there's different levels. One year, this will change how much. What we're doing right now? So you rate these ones? Right, so, and you know, like, the part of the school ship, that's actually just changing. So, like, when you change. And the reason why.
and then the year is second whole one.
Yeah, exactly.
Yeah,
probably ones that you want to see it. You know,
So what are we doing? I said, no, yeah.
So,
Thank you.
So part of the problem is put this on the second line. So. So. And you're gonna put it here. You see, it's really important to not put the intersection because otherwise it creates straight. It is going to be like, for everyone has to center lines. You guys know what I'm just talking about? Oh, I know.
Studio. We got all these five in here, this, and then put 8 next. Sorry. It's a TC pattern. We got all these lines and. All the lines are. Yeah. Yeah. Or not? Oh, well, okay, I will see just a little bit, yeah. Okay. And then put 8 instances. Oh. No. We're gonna try that again. Try to do the same thing if the problem persists. Let me know. Take it to your phone. Everyone else ready to keep going? All right. So once you have this, click the check mark. That's fine.
You're one that says.
All right, is everyone there? Click the green check mark so it actually finishes. And once it loads, I'll get you to the next step. That was the goal. We'll see if we make it there. All right. Yes, once this loads, we'll move on. And my screen is frozen. Yes. Great. And everyone over there, yours is working now? Is yours working? No, what's your name? Sorry. Well,
Okay. It's not.
What happens here?
I think this is the problem. Okay. Whatever line is there, it's cutting around that line instead of around this one. So, yeah, try to. I'm sorry, there's no more. Is a little bit of a program that I thought was there. This is the one we teach this for like but it's not it's up. No, can you zoom in? There we go. Okay, so we got that other one. Okay. Eventually it will load. That looks like mine is over, so you can move on. All right, does everyone see this? Black lines? Okay. So. What happened? All right. Now we're going to get our first extrusion. That's exciting. Everyone go to this features tab. All right, you see it right there? Features. This is where you do your 3D modeling. The features, and you're going to hit extruded boss base. Everyone at extruded boss base. Extruded boss base. It's that very first button on the left-hand side. You see it? Okay. And then you're going to click on right there on that space in between. You're going to click on the space in between the outside and the gear teeth. Do that. And then you're going to extrude it to 0.5 inches. And you're going to extrude blind. Blind means just like out, you know, to whatever direction in whatever dimension you specified, whatever depth. But there's also like up to vertex, up to surface, offset from surface, up to body, mid plane. There's also like a through wall if you're extrude cutting through something, right? So up to surface would be like if you needed to like match another surface, or through all would be like if you're cutting through an entire surface and if you're cutting through part of it, which you'll see later. But right now we're just doing blind. It just means, you know, just extrude from whatever sketch you created and then hit the check mark. Does everyone get that? Makes sense. Maria? Oh. And here we go. Now I've got my ring gear, finally. Ta-da! That's how you got it. All right. No, don't grab it. Just click that surface. Yeah. You see that now that's showing the preview in yellow? And then we go on slide, it's right there. Quite heavy, that's how long it is. All right. And we can load and show you. Yeah. Okay. I know, you did, all right. All right, everyone, where are you? Yes. Are you good? Rhea? Yeah. Yeah, okay. All right. Now, what you're gonna do is you're gonna go to front view. So click this down arrow right here and click front. And that'll get you, so you're like straight on looking at it. Then what you're gonna do is you're going to click on this, right click on the surface and hit this button here that says sketch. All of you, this is working for you guys? Good? Got sketch? No, just regular sketch. We're creating a new one. Sketch should be right under edit sketch. It's on the bottom. This is edit sketch, this is sketch. You want sketch. What this is going to allow you to do is it's going to allow you to create a new sketch on top of the sketch you just created. Or excuse me, on top of the part you just created. And what we're gonna do is we're gonna do exactly kind of what we just did, like circle. This is how we started, circle, right? Origin. What on earth? Circle, origin, and then, you know, new circle, new geometry, and escape. You should have people. Yeah. You make it any size, you'll do it. Okay, so you're an edit sketch, you need to be in sketch. So, like, here on this. Yeah. Then sketch. And then, yes. So you're like, yeah. Then bring it, yeah, that's perfect. Awesome. Yes. Okay, so right click on your surface part. That's right, so we will sketch on it. And then right there, that's it. We'll let one from there. All right, everyone there? Good? How are you guys doing? Thanks. Now, here's a little bit, but that's fine. Click right there on the surface, right click. Right. Then hit. Okay. Right there. Yeah. So sorry. This will be online later. I'm so sorry. Right click on your surface. And then hit sketch. Oh, what works, right? Oh, that's one. And then choose sketch. And create a circle. Yeah, drag it, you know, out there, but yeah, it was. All right. Everyone good? Okay. So now we're going to dimension this again. And this is going to be, I believe, 7 inches. Sec. All right.
You said the circle would be 7 inches.
7 inches, yes. And now, much simpler than we did before, we're going to extrude this. So features, extrude, and then this is going to be the same 0.5 inches. Hey, how you doing? Good? No? No? The other direction, yes. So point my images, point my images. What is your-
How do you get I'm sorry. Always get and then. we did that one second. Right, and then
Just click on the surface, yeah. Right there. Go on side. Go on side? Yeah. Yeah, then drag it up 7 inches. So click, yeah, and hit 7. Or that. So you go to features. Oh, true. And then one in, see, now quick coverage 0. That's perfect. Check mark. Alright, and then let us do this way. Yeah, there you go. Alright. Yes.
What if you want to do the force or features?
Features extrude point images. You should have point images of the year and then another point images of this back end. Everyone good on that? I'll do 2 minutes and then let me know when you're ready to move on. You guys having problems? You guys are good? Try rotating. Try. I don't know if you know, and then check out there. Try holding it and. You know what? Go right up there. Yeah, and go to the isolation. The isolation up here, just the view. Oh, right. You should be able to rotate it. I just don't know how to do it like that.
Yeah, you put it.
Okay. Okay. There we go. Okay, so just press and hold and slide it whichever way you want to go. Yeah, and it's good. It's weird, but hopefully that's working enough. It's much if you use the mouse.
yeah.
Like, does that make sense a little more now? Okay. Is everyone here? All right. So what you're gonna do, you're gonna go to you're gonna go to the right view. So click on right, like that, so you can see the whole thing in profile. And click on right plane. So the right plane, you can see it goes right through the center, but it's kind of a cross section. Right plane, yeah. So click on right plane, and then click on right view. You can also click on the plane and click normal, but same thing. Everyone look like what my screen is showing. No? Okay. You guys get back there? Yeah? Okay. So what you're gonna do is you're going to click on the plane and click sketch, just like we did before. Right click on the plane and hit sketch, yes. Thank you, Chantal. All right, is everyone else good? Okay. So that run sketch, what we're gonna do is we're gonna do convert entities this time. So click on this line right here. You see the right in the middle? The one that's in the orange? Click on that and click convert entities. We're gonna do the same thing with this top line right here. So now you've got two thick black lines perpendicular to each other. Does that make sense? So what convert entities does is it takes like lines that exist in other features and moves them into your sketch plane. So you can now use them for geometry.
This one at the top, right?
Yeah.
Select the plane.
It's like the plane.
You do this, it's on time. Put it right there, and then I'm going to do like this, box there, button this. So I want it to sound like this on my, but then first plate, I want this, put it on top. Okay, oh, here, and then it's on the right button. And then, so now, yeah, you sketch. Okay, so you are in sketch, okay, good. And then for entities. So in convert, click the line.
We also convert the bottom one.
No, just the top one. Yeah, and then do the same thing without limit there. The top one, right, without. Make sure, yeah, make sure it does like that. Great. All right, perfect.
All right, now what you're gonna do is you're gonna do another arc. So click the 3-point arc tool just like we did before. And you're going to click on this point and this point and make a 90-degree arc. And it should snap to 90 degrees, but if it doesn't, just dimension it. All right, 3-point arc, yes.
Which one's different from that?
From this point,
Yeah, no,
How does it,
the arc, it's this arc tool, the 3-point arc, just like we used before. 3-point arc. 3-point arc. For this is exactly what we did to create the gear teeth. It should, when you do it, it should give you, let's see if I make it again. You see when you hold it right there, it says A equals 90 degrees, R equals 0.5.
Oh, okay.
So Maria, do you see how right here where I'm hovering, it says A equals 90 degrees, R equals 0.5? So it'll tell me that information when I do that. And it should snap to 90 degrees. Does everyone have the arc? Yes? What? Let me see your screen.
Oh, okay, so just do it again. Yeah, those 2 buttons. Yeah, and then make sure you're bringing it out. Otherwise, if you bring it towards the center, it'll see how it works. It'll go over and go upwards. Go outwards and go back. All right. Now.
So now we're gonna do is you're gonna trim entities again. Ever remember the trim entities tool? The trim entities and then just take out this one line right there. So you just have this semicircle. That's what you want. Okay, you're trimming this one line right there.
The trim off the middle one?
It's the line that was right there. Oops. So you had a long line, you just want the part of it that's right there. So just a semicircle. All right, everyone good?
You are trimming that one. No, I cut this portion of it, you want to get rid of that one. No, you see about this one, you want to keep this part, and get rid of that. You see how these are thicker lines? Yeah, so you see how it got thinner? Because geometry is still there, but that's what's behind it, thick lines is your sketch. It takes some getting used to.
I see the same.
Yeah, it's faint, these lines are like a little bit thicker and blacker.
No, like this one, we don't have this one.
I do. Yeah, and you can kind of tell that it's a closed sketch now, because with that extra line, it wasn't closed. Like that kind of extra geometry. Yeah, it's hard to explain, it's just, it takes some getting used to it, to how it looks like. Yeah. I'm sorry, it's not your fault.
I know.
It's the program, it's a hard program. Yeah, I promise it's not your fault. Okay, everyone get on this. Okay, well, first we sketch. So hit right plane, and then hit sketch. That many problems you want sketch. Okay, so hit that line. Convert things. And then hit the top line and do same. Yeah. And then draw that mark. And trim that extra. Looks like you didn't convert any of these. Convert like these. You want that line right there. That one. Yeah. Then hit check. And then do the same thing with that one. Yeah. It's not you, it's the program. Yeah. Yes, just that. Make sure it's open when having knowledge. Oh, it's not a window. No, it's seven's just fine. Seven's good. Yeah. Okay. And then you're gonna trim just the edges of that line. This part, see how that's, yeah. Trim that. And see, do you see the nut closes? Because now it's closed geometry instead of that part. Maria, I think part of it also is that you're in the virtual lab, and the graphics are just worse on the virtual lab, so it's harder to tell. Okay, everyone have the arc, the half quarter circle. Okay, this is important. You go to features again. Remember, that's where we do all of our like extrusions. But this time you're not going to do extruded boss base. You're going to do revolve boss base. Hit that. Oh wait, no, don't do that. I skipped the step, sorry. What did I just do? Okay. I forgot a very important step. I'm sorry. You're going to go to center line again. And you're going to draw a center line through the origin. Doesn't matter how long it is. This is its reference geometry.
Are we doing this to fill in that?
All right. How's everyone doing? Do you have the center line? Okay. So now you're gonna go to features and revolved boss base. And it should automatically generate this, but if not, just fill this in. So the axis of revolution is that line you just created. And yeah, it should be blind 360 degrees. Features, go to revolved boss base. It's right here. You have it? Is it showing you the preview? Yeah,
How many?
360. Got it? All right. Everyone else? Yeah, I think those of you who are in the virtual lab are having a much harder time with this because like it's just not as good of a program. Yeah, the virtual lab is just a pain. If you get onto the actual SolidWorks software, it's much easier. Does everyone have this? Does everyone see what I see?
Oh, that's fine, just click. Just click on like, yeah. Yeah, that's fine. All right, everyone else doing that? Are you guys seeing this?
So.
Okay, go to, sketch. Trim. And then trim that one right there. Yeah. So if you're gonna do trim, you have to like start someone else and then just start there, yeah, just there. Yeah.
No, it's just not.
Yeah, so you can roll them. Okay.
You just respond. That's worse than the news.
Sorry.
Oh,
Yeah, I think it's the virtual lab. We just talked about the apps.
the new one. Well, we're not new, it's on the board. But they used to do that one.
Do I come to the best?
It's just not. Um,
Yeah, the one.
Oh, yeah. It's not.
There we go. Yep. So what did you do with someone? So did you like starting here and then going out?
Yeah.
I think that's what happens. It needs to be through the whole thing.
Oh.
So let's see.
Oh, I'm from.
There you go.
It's you.
Yeah, no problem. All right, everyone else good?
All right. Sorry, I know this program is a kind of a pain. All right. So we got this far. Let's go to, okay. Let's do the hook because I get to show you how to use the sweep tool. I don't know why this thing needs a hook. It doesn't. I just need to show you how to use the sweep tool because it's useful. So what you're gonna do is you're gonna go to top view. Like that. And we're going to create a reference plane. So you're going to go to this reference right here, reference geometry, and click plane. Does everyone see this? Let me know when you do. You got it? Okay. Everyone else have this, the plane? Okay. So your first reference is going to be this surface right here, the circular surface. You're going to have a tangent plane on there, but you see it's tangent kind of everywhere, or it's not giving you control over where the tangent is. Your second reference is going to be the top plane. Which is, that's not how it's supposed to work. Wait. Oh, I know it's, okay, top plane, you have to click parallel. So now your reference, your tangent to this circle or cylinder, and you are parallel to the top plane. Does that make sense? So once you've got these done, you're gonna hit the check mark.
So these like the references in the show.
Did you see where it says first reference? Hit that box, and then you can select a surface. It's this, the blue one right here, the tangent surface, and it should automatically default to tangent. It should default to tangent.
Yeah.
Okay. And then the second reference, you're gonna go to the top plane. So if you can click this down arrow right here, the black one, by your part, and click top plane. Does that work?
Yeah.
Okay. And does it show what it's showing on mine?
Default perpendicular. Okay.
Default, if it defaults perpendicular, change it to parallel. All right, you're seeing this? All right, and you're good over there? Yes? Sorry, I'm sorry, what's your name again? Okay, so just like, yes, or I would say try to lead it, but. So go to reference geometry.
I don't know where to get from.
Great.
Oh,
First reference?
I know.
And then second reference.
Oh, what are you doing?
Oh, no, it's just a chat.
Oh, okay, think of that.
Yeah, we put space. Okay. So this is why it's being third, because you already put one. Yeah. So if you're gonna use these boxes, but. Second reference. All right, and now it's fully defined, you see that green box. I love, yes. You don't need the reference. As long as you get that box that's fully defined, so we want. So if your plane is not fully defined, you'll get an error, but as long as you can define exactly where it is in space, you're good. The third reference is only if needed. Yeah. Now you're gonna do top view again? All right, is everyone in top view? All right. So, excuse me, sorry. what you're gonna do once you're in top view, click that plane and you're gonna do another sketch, right? So right click and then hit the sketch button again. So you can sketch on that plane now. And actually you can move this plane if you want because it doesn't need to be there. Or it shouldn't, whatever. There we go. I just find it annoying. As long as you're sketching on a plane, the plane extends to infinity, so you don't actually need to be on the plane that it's showing. It'll still allow you to do the same stuff. Huh? Right click the plane and hit sketch. Give you a sketch option. Yeah, right there. That's what.
Is this
That's sketch. All right. So, and everyone, where I am. Okay. It doesn't matter. You can sketch on or off that plane. I just find it annoying. As long as you have set the sketch plane to be on that reference plane, that plane extends to infinity. So it doesn't matter like where it is. Like you can extend it as much as you want. You're still sketching on that plane regardless of what's being shown. Does that make sense? I know it's a little weird. Yeah. You're still sketching on the plane even if the plane isn't physically showing. So now we're gonna hit the circle button, which we've done before, right? And we're gonna sketch right here on the top. Make that circle and hit escape. Got it? And then we're gonna do the dimension. So it is going to be 0.125 inch diameter. Huh?
So the sketch circle in the middle of that.
Yeah, sketch a circle right there on that side. On the outside of the cylinder. I can't talk, I'm sorry. And this is gonna be 0.125 inches. And then you're going to make this click on that line right there. Yes. And then you're gonna make it 0.25 inches from the edge. So it's dead center. The other thing you're gonna do is you're gonna make it 3.5 inches from the side right here. And that is also gonna be, again, so it's centered. You can't see the dimensions, can you?
Now we want to make sure that this circle is. And now we're going to at this point, instead of 0.25. So 0.125 diameter. 0.125. We'll click right there, and then we will set. And then we want 0.25 from the top one. That line is the center. Yeah. Then do the same case, 3.50. Oh, you're perfect. Okay, then, yeah, the exact same thing with that. Now it's got 3.5 inches. Yeah. And then we're all good. Yours is the one of the only. Oh, yeah, because my senior. That's and then. Yeah, I did. Get the hang of it, that's fine. Yeah, that's true. My teacher used to have stroke cuts on the computer, so then he would go by himself. Yeah, so that's it's over to my. Yes. I don't really know. Not yet, not yet. Oh, yeah. What? Right, you know what? It doesn't matter much. It'll look a little bit, but it's not. Yeah, I think all of you that are in the virtual lab are having issues. Oh. Huh? She went, yeah. No, I mean, just like in general, the virtual lab makes it harder for you to follow along. Right? Yeah, I don't know. It's very clear before. It's like you sent me in the right dimension and then it's default in different dimension. Yeah, so all right. But also able to do the rest of it. It's not gonna be a problem. Okay. So once you've gotten here, what you're gonna do is you're gonna exit the sketch. So click this green check mark right here. So that exits the sketch and you're going to get grayed out. You can also click this plane and just hit, if you right click it, you should be able to see the hide button. It'll look like a big eye and you just hide it. And that's just for like convenience purposes. So you are now going to go to, excuse me, go to front. So you're seeing it in this profile. And you're going to do a different sketch. So the back plane and hit sketch again. No, actually, don't do that. Good to see you. Bye. You're actually gonna do is you're gonna click sketch it on the right plane. Because that will get you, it's intersecting. So that'll get you right there. So sketch on, oops, right plane, sketch, yeah, already there. And then just put it in the, go to the right plane view. Excuse me, right there. Is everyone seeing this? I see that.
Okay, so click on right plane in the navigation bar right here. Do you see it? Click on it. It's there, okay. And are you sketching on it? So click on click on right plane and hit the sketch option. Yes. No? Okay. What we're gonna do now is click line. It's just regular line, not center line. And hit the center of the circle right there. Click the center of the circle. And then just do a vertical line. And you'll see again. You see when vertical sketch relation appears, that vertical line right there next to the cursor. Make sure you're seeing that. And you're gonna anchor it and dimension it 0.5 inches.
Yeah. Oh, that's like. So that's.
What's going on?
Oh, no. And so there's this, like, 90. So what, maybe.
Wait, Chantel, is she in the front view?
On your side, but it's just.
Oh, okay, cool. Yeah, it's not gonna matter. All right. Yeah.
Then try dimensioning it. No, okay. Well, that is just the line. Oh, yeah. Yeah. And then I wrote like this. Oh, okay. I mean. Honestly, it's fine. You're just. Yeah. Yeah, like you said, I can measure. This like this, right? Big on already. Yeah. Sounds good. Yeah. So just connect the exit sketch button right there. No, not that. The other beginning. It depends on if you're making it, like if you're building something fully from scratch and you're just designing it, you can guess the dimensions sort of, and then this one next to this one. Yeah, sure. So, yeah, okay, so let's say you have a circle board and you want to make a box for it to protect it or something, right? You would measure the box length and then you would put that up there. Yeah, then you want the lid has to be similar or less size of the box. And then you have to assemble it, which is the next. And then yeah. Sometimes it like you assemble it and it doesn't like it overlaps. And you're like, okay, then that's not clean. Got it. It has to be perfect, like. You guys do that, sorry. Oh, yeah. And sometimes when you get the back. Oh, no, just like outside. But like you have to make sure because sometimes parts are $1,000, $2,000. You don't want. Yeah, when you go and then it doesn't fit, you're screwed. Oh, yeah. So what materials do you use for this? Metal or is it like? It depends on what you want. Yeah, you want to be stuck here. Then this can be metal. This is like a bicycle, you want to go. Someone else doing okay? You would download the stuff, and be like, hey, here's my part. Yeah, depending on how complicated it'd be like, okay, you're like $5,500.
Ready to move on?
Oh, this is.
Yeah, you're good, Katie? Okay. Everyone have the line. Okay. Now we're gonna do another 3-point arc. Click there, click here, and then have it snap to 90 degrees. Or excuse me, snap to 180 degrees. Yeah, and then you can dimension this. This is 0.25 inches. A length? What?
Sometimes when you do the 3-point arc, it just shows the length of it, but then if you redo it again, it shows the base. That's all it is.
Okay, so everyone have the arc. Yeah? That's the radius. That's the dimension line, yeah. Yeah.
This line? Yeah. There. Yeah.
What's the radius?
0.25. Great. This is 0.5.
Say,
0.5, yeah. 0.5, 0.25.
Now, dimension, 0.25.
What's up? No angle, no. Just 0.25 inch semicircle, 0.5 inch line. It's blue, honestly, it's not a big deal. Let me see if there's-
There we go. And then is, what you think? These things are like, yeah. Sometimes I really do that. Sometimes I get, okay, let's just start off. Yeah. But she didn't the only side though. It's okay. It's the same thing. No, it's not. It should be. It should be the at least the next. Oh, yeah. I mean. Yeah. Yeah. But it should be. It's not. Okay. Try it.
Everybody, this is where you need to pay attention. So this is the next feature I'm going to show you is the sweep tool. Sweep boss base right there. Excuse me. Actually, we're going to exit this first. My bad. So exit. Sweep boss base. Wait for it to load. See right here, the pink one on the bottom, that is your path. So you're going to choose these two right there. Or, yeah, so that sketch should be highlighted in pink. And then your sketch profile, you can choose circular profile right here, and that'll just like basically give you, you can specify a circle, what's it called? Circle diameter. And it will automatically create the circular profile. But if you want a different profile, like we're doing circle, but if you wanted like a diamond shape profile, for example, or a square shape profile, this is what you'd use. We're doing circulars, doesn't matter. But we're gonna click on that bottom circle right there. And now it's creating that token for you. Does that make sense? Does everyone have this preview showing? Profile, click the circle you just made on the bottom.
Oh, okay. I must have that this time. Oh, okay.
Oh, sorry.
It's not really for like the gearboxes.
No, no, it's just to show you how to use the tool. It's just to hang it.
Okay, we hang you the thing.
Yeah,
Okay, okay.
like it's really not needed. It's just to show you how to use the tool. Right. All right. I'm gonna see. Yeah, perfect. All right. So okay, the one up there. Is that the other one? And go to top view. And now go to the circular. Got your info profile. You create your circle? It doesn't matter. Go to circular profile. the type of 0.125.
And this seniors, we have this years.
So if you wanted a different profile shape, like let's say like a diamond or a square, you could use that tool.
This one you should take.
But for a circle, it lasts So the circle was just to show you how to use that as a tool, and you can do it without it. All right. Are you good back there? All right, everyone else good? Okay. Last thing we're gonna do with this hook is we're gonna fill it in. So I think I showed you guys, I think I kind of explained chamfer versus fillet earlier, right? Fillet you can see right here, that's just like a smooth curve. It looks like this. A chamfer is kind of like, looks like that. So 2 lines in a diagonal. So we're gonna fillet this. So choose fillet. Give it a sec to load. All right, and then you're gonna click that. You don't want kind of the surface, you just want the edge. Click the edge. And if you can see, it's not showing anything, it's not showing any preview right now. And that is because I am filleting 0.1, which is way too much for this. So it's not gonna give me a preview because it's physically impossible. So I'm going to make this 0.0625. Not 0.0.0, just 0.0. And because that is the exact, I just filleted it half the radius, excuse me, half the diameter, filleted it the radius. So it's getting me a semicircle. 0.0625, yes. And so you can see now I got a semicircle right there. All right, we're running short on time, so I'm going to skip a lot of the stuff, but I want to show you how to do a hole and I want to show you how to change the material and appearance. Everyone sound good with that? Everyone, does that sound good to everyone? I can't talk clearly. 3. But you know me, I do this under normal circumstances. I have no excuse. I know, I appreciate it, but I have no excuse. All right, did everyone get the fillet? All right. So again, because we've got like 5 minutes left, I'm gonna move on. So go to front or back view, I guess in this case. You're gonna hit this back panel, sketch, which is what we've done before. And then just another circle from the center, from the origin. You're going to dimension this. This is going to be 0.325. What's going on? What? You might have hidden it. Hit it up.
I tried.
It's okay.
Yeah, I agree.
If you guys want to next week, I can give you all the files that I made, so you don't have to go through this process. You can go through this assembly. Alright, nice job. Alright, does everyone else have that circle? Alright, so the last thing I'll show you is there's a couple different ways to extrude cut, but basically everything that you can do, like all the solid bodies you can make, the extrude boss base, revolve, sweep, all of that you can do basically the opposite. So you're gonna remove material instead of adding it. So click extrude cut. Extrude cut, it's right here. In features, yeah. And instead of going blind, you're gonna say through all. And then hit check. And now you have a hole. On our remove material, this is how you do it. I'm going to show you a couple other ways of doing it, but we are out of time. If you want to, yeah, you can also do blind and go partway through. The last thing I'm going to show you, because you got 3 minutes, is how to change the appearance and material. So does everyone see in this panel here how it says material not specified? If you right click on that, you can say edit material. Edit material. Why did it not just work? It's loading. Okay. And now it gives you this whole panel of materials you can choose from. You can custom materials if you want, but I am going to go for aluminum and I'm going to choose, I don't even know which one. This is just the first one on the list. I'm going to hit apply. And then I'm going to close it. And now my material is aluminum.
Or the steel.
Aluminum. You can choose whatever material you want. It doesn't matter. I'm also going to go to this. You see the thing that looks like a beach ball in the corner here? This little color thing. Like that. That's the appearances. So all these things will come up, right? Plastic, metal, rubber, glass, organic, stone. You can play around with materials. But yeah, I'm going to go to painted. I'm going to go to powder coat. I'm going to go to powder coat. I'm going to click and drag it here. And then I'm going to apply it to, because you can apply it to a surface, you can apply it to a feature, to the body, or to the entire part. I'm going to apply it to the entire part.
Where do you go to get that?
It's this little beach ball looking thing right here in the corner, on the side. And so now you can see I've changed the material.
Once you take that, why else you do this? It doesn't do,
Once you click the beach ball, it should pop, this appearance panel should pop up. You see it?
Yes.
All right. Does everyone else see appearances? Yeah? No? No? Okay, it's the beach ball thing right there. What's up?
So my mouse is, it's like the middle button, I press it, and I can't move my.
And it just started like right now?
Oh.
Oh, gosh.
There's something like representation.
I'm so sorry.
But, that's really fun.
Yeah, so you can play on these materials as much as you want and appearances. You can go to and I'm an amethyst. What? Yeah, and we have years of practice in this. This is the class we take like in our freshman year, so we've been doing this for years. So I'm in amethyst mode right now. Go.
Yeah.
Just for fun. Yeah, I think there's a water option. Let's see if I can find liquid.
Oh, yeah, I see the upper one.
Let's see. Let's try orange juice just for fun. Orange juice. Who knew? I'm gonna go back to the original one because I liked that. Let's see. Stone maybe? I can do Old English brick. I'm gonna go back to painting though. All right. So it's 8:02, so I think we need to be done. But did everyone have fun today? Who here hates SolidWorks now? All right. Well, thank you guys for coming. I hope you guys come next week. I can show you how to do the drawings like this, how to assemble parts. I apologize for the crazy. It's the nature of SolidWorks. But yeah, if you have any questions, always you're free to DM me and I'll answer as best I can.